Hello guys, you are with the Tech Science. Today we discuss a new point, that is thermal energy based electric power station. In short, it is called as the thermal power station. Actually, this is the chapter from the 10th standard, and having the 5th chapter belongs to science 2. That is, the name of the chapter is towards green energy. And here we have one flow chart, and it's a very easy way to understand how the thermal energy, means the thermal energy get converts into the electrical energy. So let's start with this flow chart. Afterward we have the diagram, and again there is a explanation, detailed explanation on the diagram also. Here first of all we have the fuel, and this fuel, as a fuel we used coal as a fuel, and this coal having the chemical energy, and this chemical energy is utilized in a boiler. For what purpose? To boil the water, because inside the boiler we have the water. And when we use this chemical energy by using the combustion process, we utilize the chemical energy and it gets converted into the thermal energy. Because of that, the water gets converts into the steam. Internally some techniques are there. Example, some kind of turbines are there, and these turbines convert the steam into the property which having the two property. The first property, that steam it having the high temperature, as well as this steam having the high pressure also. This is what the like two properties which are specially we are designed for. What purpose? Because this steam further fall on this turbine, and when this steam fall on the turbine which having these two property, because of that the turbine start to rotate. When the turbine start rotate, ultimately this turbine is connected to the generator, and generator start rotating. Inside the generator, magnet is there. That magnet start rotating, and as per the principle of electromagnetic induction, when the magnet start rotating, here conductor is also there. So here the voltage get induced in a conductor, and that produces electrical energy. In short, when the generator start rotate, electrical energy get produced, and because of that electrical energy we got current, and this electricity we are using in our day-to-day life. Now question is what? Here the steam after get rotating, because of the steam which get fall on this turbine, after rotation of turbine, now the steam which having the property of high temperature and pressure, it get reduces. The level of high pressure and the level of high temperature get reduced. Now question is what about the steam which is left after falling on the turbine? The answer is that now we have a system, and this system is what? It is used to convert this steam back into the water. And this water again we utilize for again we reuse, and it is again enters to the boiler, and again it will be reused by us to generate the electricity. And for this reason, the system, what is that system? We have the two things. First of all, we have the condenser. Plus we have the cooling tower. So using both of these, this condenser is used to reduce the temperature of the water, and the water get cooled by the condenser. Continuously there is a flow of water from the cooling tower. Whatever the heat energy that will be extract from the steam, and that get converted into the water, that heat energy will be absorbed by this cooling water which is coming from the cooling tower, and that water they get converted into the warm, and that water again move towards the cooling tower with the help of pump. And now the vapors and these cooling tower release the heat in the form of water vapor, that is extract with the help of the cooling tower into the air. So if you observe the diagram, you found two kinds of tower. The first is cooling tower, and second is called stack. This stack is near to the boiler like this. Here there is a stack, and this stack also release the gases. What kind of gases? These are the gases, nothing but carbon dioxide, nitrogen oxide, sulfur oxide, etc. Whenever during the combustion process the soot particle and the gases, they are released from the stack into the environment. So these two types of tower also you found in the diagram. Let's see what is the diagram is there, and using the diagram you got clear idea. So this is what nothing but just a flow chart, and using this flow chart you can easily find out what kind of execution is going on regarding the thermal energy based electric power station. Here also we have one more chart. If you observe in your syllabus, what is that chart? This chart is concerned with the energy execution. What is it? It is nothing but the energy execution chart. regarding the thermal energy, thermal based electric power station. What is that? It is nothing but CTK2E. In short, I am writing this word CTK2E. What does it mean? What does it mean? It having the first energy, it is called chemical energy. What is that? It is a chemical energy which is present in the coal. And now this energy converts into the thermal energy, and because of that the water get boiled, and this is converted into the steam having the high temperature and pressure, and that is for on the turbine means 1K. K2 means K plus K. So the first is K. This K is kinetic energy which is present in steam, and this kinetic energy which is present in the steam which is present in turbine, which is fall on the turbine. After that it get converted, the turbine start rotating, and when turbine start rotating, automatically generator start rotate. So second type of energy is kinetic energy which is in generator. Why? Because the turbine is connected to generator. So as turbine rotates, generator also rotate, and finally this results into the electric energy. It gets converted into the electric energy. So you got 5 types of energy: chemical, thermal, kinetic energy in turbine, kinetic energy in generator, and finally you got the electricity. In short, you can use this word CTK2E. Let's start with a demonstration with a real diagram which is present in the syllabus. Okay. Hi guys, this is the screen which ultimately show the thermal energy based electric power station. Here, starting from the boiler. Why boiler? Because it is a source of the electrical energy. Inside the boiler we have the fuel. In presence of air, this fuel get burned, and we have the water also. And here this water get boiled when you providing the heat energy with the help of the fuel, and here as a fuel we used as a coal. Combustion of coal is going on, and finally the water which is ultimately get converts into the steam, and this steam again get converts into the high temperature and pressure, and this steam is further provided to the turbine. When the turbine get rotated, the steam which is having the high temperature and pressure, when it is fall on the turbine, what happen here? The turbine get rotated, and when the turbine gets rotated, ultimately this turbine is connected to the generator, and inside the generator magnets start rotating. And as per the principle of electromagnetic induction in a conductor, when a magnet start rotating, automatically voltage is induced. Ultimately you got the electricity. So here boiler as a source of fuel. Number 2, this is the boiler as a source of fuel. Here the combustion of coal is going on, where the water get boiled and it converts into the steam which having the property. What is the property? High temperature and pressure, which ultimately fall on the turbine, and because of that the turbine get rotated. Finally this turbine is connected to the generator, and ultimately the generator rotates. When the generator rotates, automatically you got the electricity. Now what happened here? After that, when the steam which having the high temperature pressure once fall on the turbine, and once the turbine get rotated, now that steam which is having the high temperature pressure, that high temperature pressure get reduced. Now it's time to convert that steam into the water, and we have to reuse that water. For this reason we having the 2 things. Number 1, we have condenser, and number 2, we have cooling water. Number 1, we have the condenser, and number 2, we have the cooling tower. So with the help of this condenser, what we just cool that steam by taking out heat from that, and this heat will be given to the water which is present in the cooling tower. And here you have found that pump is there, it continuously circulates the water. So water which is coming from the cooling tower, so that will be heat will be given out by the condenser, that just gives pass to this water, and the remaining steam is get converted into the water. Now this water which is now it is completely warm, this water again move into the cooling tower, and it release the heat in the form of vapor and the hot air, and this water now it get cooled, and this process is going on. In short, we reuse with this water, and this water with the help of the pump again we are using for the boiler. So here this boiler again heat the water, get converted to the steam, and that converts into the high temperature and pressure, again fall in the turbine get rotate. That when the turbine get rotate, this turbine is connected to generator, again generator rotate, and so on. This process get continued, and we got the electric energy from the thermal energy. Now this cooling tower has some kind of like function. What is that? Whatever the water heat will be there, that is absorbed by this water, that will be given out. What is the use of this one? That is, which is present at the left hand side, it is called as stack. So during the combustion process, the soot particles and the smoke will be there, the dust will be there. So that soot particles and smoke will be released through this stack, or it is also called as the tower, also called as the chimney. At this stack having the very higher height is there. Because of why? Because during the combustion process, whatever gases are released, these gases will be released into the atmosphere with the help of this stack, as well as soot particles are also released. So this is what the diagram which shows the combustion, using the combustion process, using the coal as a source, as a fuel, you can generate the electric energy. Now there are some of the drawbacks are there. If you observe here only you found out the drawback. What is the number one drawback? Number one, whatever the gases which are released during the combustion in a boiler, these gases harm for the environment. For example, greenhouse effect, acid rain, harmful gases are there like carbon dioxide, sulfur oxide, then nitrogen oxide, and so on. This is the first thing that in ultimately maybe a problem arises because of the global warming. Second, whatever the soot particles are released, these soot particles also mix with the environment in the air, and that cause a respiratory problems are there. And last one, the fuel which is used by us in a thermal power station is a coal, and right now the coal is in limited, having the limited source of energy is there. So it may be a problem arising in future, coal may be available or not. So these are some of the drawbacks are there. Okay, so this is a complete diagram, shows how the thermal energy is used to generate the electrical energy. Okay, thank you.